Welcome back to all my viewers who have been watching part 1 and part 2 of Simplifying Radicals. We had a barn burner of a session last time with the example A through F. We basically learned two methods, looking for perfect square or going straight into the factor tree. Okay, so we're going to do a few more examples. These are going to have some variables in them, okay, but they're going to be a little bit easier, I hope. So here we have our first example, which is square root of 16m cubed. This index is 2. Okay, square root, obviously, so we're going to look for perfect squares. This one's easy to look for perfect squares. We don't necessarily need a factor tree here. So I know this is going to be equal to square root of 16 times the square root of m squared times the square root of m. Okay, I can simplify this. This is going to be 4. The square root of m squared is m, and then we are left with the square root of m. Now, if you're wondering how I did that so fast, it's because I did it with, I've been doing this a while and I've had lots of practice. So let me show you the factor tree method, just in case you're confused on how to do that. Actually, let me just shrink wrap this. In case you're wondering how to do that with variables. Because a lot of people get tripped up by variables having exponents and then taking the radicals of those. So I'm going to show you that it's not as bad as you think, okay? So I'm going to rewrite the problem so we have enough room. We have square root of 16m cubed, okay? So I'm going to separate this into two problems. I'm going to kind of put my variables off to the side so you kind of see how that works. So square root of 16, obviously that's 4. You should be able to get that. But what about the m cubed? How do you do the factor tree on that? Well, we do the same, basically the same thing, okay? So we can say that this is the same thing as m times m squared, where m is prime, m squared is not. M squared can still be broken down into m times m. Now we have all our prime factors of m cubed. We're going to circle 2 of them, so that means one m comes out and then 1 stays home. So we have m radical m, and that's why we got this over there, okay? Another way to think of it, okay, is we have m times m times m. So we just write it out. So if we have m cubed, we write it out 3 times. And if it's a square root, we're just going to be looking for anywhere we see 2, and then 1 is going to leave the house and come out in front like this guy, okay? That's another way to think of variables in case you're having trouble with those and taking the roots. Oops, sorry about that. All right, let's move on to the next example. We have, I'm going to go straight into probably the factor tree method unless it's pretty easy, okay? So I'm just going to separate these into cube root of -8. This one has a negative sign inside the radical, but it's an odd degree, so we can do that. Then we have times the cube root of x to the 4th times the cube root of y to the 5th. I'm separating these because it makes it a little bit easier to take the roots. Now, we should know, based on your practice from the other sections, that the cube root of -8 is -2. Okay? So I'm going to rewrite this just like I did in the previous example. I'm going to write 4 times itself, excuse me, x times itself 4 times. Then I'm going to write times, and then I'm going to do the cube root of y times itself 5 times. Okay, now, how do I simplify these variables? Well, I'm looking for any time there's 3 x's and there's 3 there, and that means 1 is going to be able to leave the house. So then I have cube root of x. This guy stays home. Okay, same thing with the y's. I'm going to look for anywhere I see 3. So there's 3, and then these 2 are left home alone. So I have 1 leave the house. Cube root of, and now I'm just going to multiply y times y, so I get y squared times, and then times -2. Okay, let me multiply everything out in front. -2xy cube root of xy squared. And that's my answer. I know that doesn't look very pretty, but that's what you get. Sometimes you just got to work with the cards that are dealt to you. Here we go. It looks like we have only 2 more examples and we're getting into the last section. I know you guys are probably thankful for that. Okay, so then we have a negative, and we're going to do the, I'm writing kind of some space in between just because we're just going to apply the negative at the end when we're done, okay? So then we have 32, the fourth root of 32, times the fourth root of y to the 9th power, okay? 32 is, there's no number times itself 4 times that gives you 32, so we're going to have to factor tree this one. So we get 2, 16, 2, 8, 2, 4, 2, 2. We're looking anywhere we see 4 2s, 1, 2, 3, 4. So we're going to have 1, 2 leave the house, 1, 2 stay home. And this is a fourth root of 2. Don't forget the minus sign. And now we need to do the same thing with the y's. Okay, I like doing it this way with the y's. So then we have y times y times y times y times y times y times y. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 y's. 4 are going to be able to leave the house there, 4 together, and then we have 4 together there. So that means we're going to have 2 y's leave the house and only 1 stay home. So then we have y times y and then times the fourth root of y. That's y squared times the fourth root of y. Okay, so now we need to combine everything that's outside the parentheses, or excuse me, outside the radical, which is the 2, the negative, and the y squared. And now we're going to combine everything underneath the radical, which is 2 and y. So let's go ahead and write what that result is. That is negative 2y squared, fourth root of 2y. And there's our answer. Okay, here we go. So now we have the 9th root of 5 to the 6th power. We also showed a different way to do this one earlier in the previous notes. Okay, so one way to do it is you can rewrite it as 9th 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5. Okay, now here's the problem. If you're looking at this and you're thinking, oh man, I can't simplify. I don't see 5 times itself 9 times to get it simplified there. Okay, so anytime you have a radical with common factors, see how this is a 9th, the index is 9 and the power is 6. They have a common factor. So what we're going to do is we're going to change it to the exponent form for rational exponents. So the 9th root can be rewritten as 1 over 9, and obviously the 6th power is just written as itself. Now we're going to do power to a power. We are going to multiply exponents. So then we have 5 to the 6 over 9 power. Well, 6 over 9 can be reduced to 2 over 3. So we have 5 to the 2/3 power. 5 squared, that's what that top number means, and then we have that cube root. And there is our answer. That is a reduced form. So using our typical method, it doesn't look like there's an answer, but in actuality, there is. Okay, we only have 2 more problems, so we are going to proceed as planned. But that will be right after this little commercial break. See you next time.